Hey guys, it's Rohan again, and in this video, we're going to be going into the concept of model view controller, which is a software design pattern which is really important to iOS, and actually just programming in general. So we're actually not going to be using Xcode and not going to be doing any specific iOS today, but I have a presentation to describe and explain the concept of model view controller. So to start with, actually, okay, so it's model view controller. It's the essential design pattern for iOS apps. So let's say that you're making a game. That's your app. You're calling it Rockets and Planets, and you basically move around a rocket to avoid the planets. So let's say this is your screen. So what things do you see? You see a rocket, some planets maybe, but on the inside, how do we actually describe a rocket? And this would be in our app. What can it actually do? And how do you describe a planet? What can it do? So you have this table of, this is our model. It has exactly what the rocket and what the planet can do and their attributes. So let's say for our rocket, the attributes would have a direction. It always has a direction that it's going in. This is in Swift, maybe you could relate this to a variable. It has a velocity, speed, basically, that it's going in that direction. It has a color. It has a location. So, and then in terms of behaviors, more like functions actually, like actions, remember? Functions of a rocket would be turn, accelerate, decelerate, fire the laser of the rocket, maybe to blow up the planet. So, but then for our planet, we'd have similar set of things: color, radius, rings, location, all attributes, and behavior: rotate, orbit, implode, explode. So there are these things, and this would fit inside our model, and that's the part of the model view controller. That's the model in model view controller. So this is our view, and so our view is actually just what the users see and interact with. So like I mentioned, we said, what do we see? We see a rocket and a planet, right? But actually, these aren't real rockets and not real planets, obviously. They're representations of a rocket and planet. And we don't really touch the rocket or the representation of the rocket, maybe. We don't actually touch it. In terms of our app, the app, all that the app knows is whether you're touching maybe the image of the rocket. You're not really touching the model because this is the view. This is what the users see and interact with. So this does not connect directly to the model. So maybe they could tap it, swipe it, something like that. So going on to the controller, so the controller orchestrates view events and model changes. It's kind of like the disputer between the view and the model. So let's say a rocket doesn't know anything about being tapped or swiped, like when we saw in the model. It doesn't. It just had maybe turn, it had accelerate, decelerate. So then the controller connects the events of the view. Maybe remember we had the tapping and the swiping. And then the controller can in turn tell the model to turn maybe when the user does a swipe. So in an iOS app, remember we had the view that we saw in Storyboard, and we created the UI components. But alongside that, we had the view controller, the Swift file, where we had certain events, like we could make IV actions. Remember when a button is pressed or something like that, and we can have labels and we can have outlets, and to change the view and in turn change the model. I know we haven't gone into actions much yet in this YouTube video course, but we will in we will pretty soon, and in the next couple of videos actually. So in an iOS app, um, So we have this controller, but then the model would be maybe a separate class or something. We were actually working with models in the clock app a little bit, like these little classes or maybe structs, something like that, that the controller could update the model when something happens in the view. Like if a rocket hits, or no, let's say a rocket fires a laser at, well, actually, there's a better example right here on the slide. There's the user swipes on the rocket in the view. Input of that goes to the controller, basically like hey, the user swiped the rocket. Then the controller handles that event and outputs it to the model, which would basically, it's not shown here, but it would basically calculate it, store the data, something like that. And then it re-updates the view, and it says, hey rocket, you got to change, you got to go in this direction, change your position. So, but on the view, the images are just moving. The controller tells the view what to do, and the controller knows what to do based on the model. So the controller is really just in the middle of these, and that's why we work so much with view controllers throughout iOS. So yeah, this is continuing. Yeah, so this is with the model, right? So we have our yeah, so a rocket model doesn't know how to draw a picture of itself or anything like that. It only knows how to move and turn. In an iOS app, when a view needs information from the model, it typically asks the controller, because the controller does never interacts directly with the model. So the view would ask the controller, where do I need to go? Something like that. But it would never directly go into, maybe you're doing calculus in the model. It would never interact with that. So then a controller then provides the view with information that it needs in order to draw itself. So this is still, remember, it's like kind of disputing the between events between the model and the view. So going on more to the model, like I said, it's often Swift classes, and it's always pure code. There are no storyboards involved because there's no UI. It's a straight up code. It's a class. So here's an example of what it would be actually, and see attributes like we saw here, direction, velocity, color, location, are properties, and behaviors are methods, also known as functions. But yeah, in a class we call functions methods. So you'll basically always be using methods in Swift. And again, now that we're relating everything back to Xcode, the view would be the user interface, like the storyboard, like we mentioned. So text fields, buttons, pictures of rockets, images, yeah, like we said, it's what the user sees and interacts with. So then moving on, yeah, so we actually see the view. You might have wondered, what actually is this view? Why can we do stuff with it? Why is it just called view? Why doesn't it have a name? It's because it's the main view, and that's just the parent of all views. Every view is inside this view. It's just it's what the user sees and interact with, just like that. And every button, text field, or pictures of rockets, they're all views, and they can be inside other views. But we don't need to get into that yet. We just need to know that a view is what the user interacts with. So moving on specifically to the controller, relating it directly to code, like I mentioned, we have the view controller classes, and the controllers are usually, like I said, UI view controller classes, and they orchestrate the communication between the view and the model. Like, right, we see Rocket being created based on the Rocket class that we mentioned. You don't necessarily need to know exactly what's happening, but if you watched the Swift videos before this, before we went into iOS, you should know that it's basically initializing a rocket up here, and I'm trying to see if I can draw on these presentations. I don't know if I can do that. Draw. can I do that? Okay, never mind. Maybe I'll figure it out sometime. Okay, but anyway, so we have, so like in this code, we have the swipes are being listened for in the event, and it's updating the model. So this is our final kind of summing up uh, summary, really, sum up, yeah. But so our model view controller summary picture. So remember, like always, we have the just in programming in general, we always want separation of concerns, and this gets into modularity, and we want to keep all of our stuff decoupled, is what it's called. We want to keep it separate. So, and that's why we have no direct connections between the view and the model. And this is good because the model code should never be about the interface, it should only be about the model. And that's because we want to be able to swap our views and our models in and out with each other for the future. It would be easier. So if we have everything working separately. So every unit of the code should work on its own, and then when put together, it makes an app. But if we want to say, let's say the designer of our company wants the colors to change, and maybe wants a new rocket image, and some other things, or maybe they have show an animation, something like that in the view. We don't want to have to change all of this intertwined code just to take out the old one and put in the new one. We just simply replace it in the view, and nothing else has to change. And the controller, as you've noticed, that's where a lot of the action is. Doesn't necessarily mean a lot of the code, it just handles everything. But because of this, we want to make sure that our controller, like our view controllers, don't become super big, because we want a lot of our logic to stay in the model class. Don't ever let yourself do like something like the rocket gravity calculations with in the controller, because that belongs in the model. Like there's a saying, you say lean controller, strong model. Our controller can do lots of things, but it's lightweight and it's thin. Our model is bulky and strong. So that's basically it, and I hope this nails down in your head, at least to some extent, what model view controller is, and hopefully you can apply it in the videos to come next and in your programming endeavors in the future. Okay, thanks, and see you next time.